Hi, and welcome to this little quickie. Today we're going to be producing a half ball, a 3/4 inch diameter half ball. Now you've heard of split nuts on the lathe. It's the part of the lathe that clinches onto the lead screw, 2 half nuts for threading. And split nuts, well, that sounds kind of painful. And today, well, we're looking at half balls. That doesn't sound painful, but it does sound a little debilitating. So, half balls, how to produce them accurately with coordinates on a lathe without a digital readout. Let's take a look at that. So what we want to do here is produce a ball, or in our case a half ball, on a 3/4 inch diameter shaft. So this would be my shaft, 3/8 is the radius, and this is half of the ball that I want to produce. Why half of the half ball or a quarter ball? Well, obviously on the lathe, when the part is spinning, I'm going to be doing both sides simultaneously. So that's why it's sketched in this way. And to do that, I'm going to produce a series of radius cuts, very accurate radius cuts. And if I add those cuts up, it will tend towards my proper radius, 3/8 of an inch radius on the end of my part. So let's take a look. You see these different circles that are accurately positioned along, you can see their center lines there, along a certain radius. In this case, a 468 thousandths of an inch radius. And if I put enough of those together, you can see that the inside of those circles create a radius, okay? And that's what I want to do. Now, imagine this is a nice radius tool. How radius? Well, a 3/8 of an inch diameter tool, so 3/8, 3/16 radius. Really nice and round, that I'm going to set up and come and cut these grooves. So I'm going to cut the first one here, first groove, and then I'm going to move over and cut the second one, move over, cut the third one, move over, fourth, fifth, and sixth. So I'm going to have a series of those radius cuts. If I do this correctly and accurately, the bottom of those radius that I've just produced, well, will come and just delimit the larger radius that I'm trying to turn. And that, after finishing, will produce a very accurate ball. Now, obviously, the more of these cuts that I produce, the more that I calculate, the more accurate I'm going to be. But in my case, because I don't want to spend a week doing this, well, I've limited myself to 6 positions, 2 of them being the zeros, which actually won't cut anything, and 4 that will actually remove some material. So, where did I get those coordinates? Well, let's take a look at that. Now, I'm not going to use the same whole circle calculator that we did in the last video. And that's because to do this easily, we need something a little more than what that basic calculator could give us. So we're going to be using a calculator that I found on a website that's called doov.com, DOOV.com, because their bolt hole calculator gives me the option of offsetting the 0 on my bolt hole circle. So let's take a look at this one. I have my bolt hole circle diameter that's 0.9375 or 937 thousandths of an inch. I don't do 10 thousandths on this project. And where does that 937 thousandths of an inch come from? Well, it's the diameter of the radius I want to produce on my part. So 3/4 of an inch is the diameter of that ball, plus the diameter of the tool that I'm going to be using, because it cuts on both sides at the same time. So, and that is a 3/8 of an inch diameter tool. So 3/4 plus 3/8 is 937 thousandths of an inch. Now, in my example, I'm using 20 coordinates, or in this case 20 holes, but I'm not drilling, so we'll call them coordinates. And I'm going to start the first coordinate on the bottom, very bottom, along the y-axis of the bolt hole circle. You can see the hole 1 there. But look at the centers of circle axis XC and YC. So X center, Y center. I've offset them to position them 469 thou to the bottom right hand of the bolt hole circle. And that just makes my life a lot easier, because I'll be starting from a 0 point and cutting towards the center of the part with the numbers that go in the same direction. And that's important because I don't want to be playing too much with my backlash, and I especially don't want to be getting confused with my numbers. So this will help out quite a bit. In the bolt hole circle video, the last little quickie, well, we saw that we could use the older versions of the Machinery's Handbook to find coordinates for bolt hole circles. And we used, at that time, a table 3 in the bolt hole circle tables, which was a type A with its reference on the center point of the bolt hole circle. And that's not what we want here. We want a center point that's tangent to the bolt hole circle. So we're not doing reference 1, we're doing reference 2. But these older versions also give us a chart for calculating the coordinates when the reference for the bolt hole circle is on at a point outside of the bolt hole circle, a tangent to the bolt hole circle. So that is another way that you can calculate these coordinates. And just mentioning, if you do that, the setup we have here with the one on the axis, well, that's a type A setup, okay? And you'll see in the handbook that table 1 is a type A, table 2 is a type B, table 3 is a type A with the reference on the center, and table 4, well, is a type B with the reference on the center. So this is something that you can use to calculate these coordinates. We're going to be cutting from 1 to 6. Now 1 and 6, we can see they fall on a 0, so they won't be cutting any material because my part is already at 3/4 of an inch. So we can not cut those, but we need them because we're going to need them for setting up. So I'm going to set up my tool, come and touch off the end here, and set my x-axis to 0. Then I'm going to back down, come over, and come and touch the side of my blank part and set my y to 0. So I have 0 and 0, and that gives me a point right here. So I'm going to back up with my x-axis past the 0 and come back to it to make sure that the backlash is taken up in the right direction, and then I'll be right on 0, 0. So once that I'm there, I'm going to want to do the first one. Well, the first one we don't do. The second one, well, is minus 324 thou and 23 thou in y. So I'm going to move in 23 thousandths of an inch, and then I'm going to cut in this direction right up to 194 thousandths of an inch. Then I'm going to back up past the 0, come back to it to get my backlash taken care of, go in 290 thousandths of an inch, up to 90. Now important, I'm not moving 90 thou, I'm going from 23 thou to 90 in the y, and then I'm going to cut to 194 thousandths of an inch. That'll be my position 3. Come back past 0, come back to 0, get the backlash out of the way, move in to go up to 194 thousandths in y, come over to 90, then back off, come to 0, move into 324, and cut to 23 thousandths of an inch. And my last coordinate, well, won't cut anything, so we don't have to do that one. That is the sequence that we're going to follow. So let's go take a look at our setup. Okay, so I have my part set up here, and it's in the forejaw for a simple reason is that I have to run true here. The diameter of this blank is the same diameter as the diameter of the ball that I want to produce. So I can't have any run out right from the get-go. So it's well centered in the forejaw chuck. I've surfaced the end of the part here so that I have a reference surface here and obviously a reference surface on the side there. So my part is ready. My tool here has the proper 3/8 diameter or 3/16 radius on it here, and you can see that I just hand sharpened this on my pedestal grinder, and then I stoned just the edge of the clearance to get a really accurate radius here. But notice it's important, I have back clearance all over but not on the two sides. That's difficult to do. I could do it, but it's not necessary for this job because I only need half of this radius, half of this cutter I should say, to do the job. So I'm going to set my tool at 45 degrees in the lathe, and that way when I touch off the end I'll have good side clearance, and when I touch off the side I'll have good side clearance. So that's how I'll get around that problem. So let's set up this tool. So I make sure I have enough room to work here on my compound rest. I get close to the end of the part but not on it, because now I want to lock my saddle because we won't be using the longitudinal hand wheel anymore. Now I'm going to approach the end of the part and just barely touch off. Going in that direction, I can set my compound rest axis to 0. Now note that I position the compound rest parallel to the longitudinal axis because I'm going to be using it to measure my distances. So that's set. I can back off, move forward, come and touch the side of the part, just barely come in contact, and set to 0. There. So now I can back off, come past my 0 in X, and come back to the nearest 0, and that is 0, 0. My tool is where I want it to be to start this operation. So we're ready to start to cut. So go and get your safety glasses and plant them solidly onto your face. It is very important. That being done, there's another thing I want to warn you about, and that is that machines come in two types. Well, there's several types, but as far as your cross slide axis goes, there's two possibilities. Your cross slide can cut on the radius or on the diameter. Now what does that mean? Well, if I move the graduated collar by 0.010 of an inch and my tool actually goes forward or backwards in whatever direction by that 0.010 of an inch, well, I have a radius cutting machine. And what that means is that if I move 0.010 of an inch, my part gets smaller by 0.20 of an inch. If I have a diameter cutting machine, the lead screw isn't 1 for 1. And that means that if I move the graduated collar by 0.010 of an inch, the tool will actually only move 0.005 of an inch. And that means that the part will get smaller by 0.010 of an inch. So diameter or radius, very important. Now my machine here cuts on the radius, And that means that I can use those coordinates that we calculated straight up as they are. However, if your machine cuts on the diameter, well, you're going to want to divide the y coordinates by 2. Now, I know that in NC work, we always use X and Z axis on the lathe, so we don't use the Y axis in that way. But I find that's a little confusing. This is just a beginner's machine shop video, so I'm going to stick with the X and Y because we're just so used to hearing X and Y. So X and Y. And other thing I want to mention, my compound rest here is always 1 for 1, so I don't have to worry about being it, do I double, do I half it, or what? No, 1 for 1. Cross slide, in my case, I use the coordinates. If not, if it's on diameter, I cut them down by 2, divide them by 2. So let's start cutting. So 10, 20, 23. That's my first coordinate in the Y direction. And now on my X, I'm going to head over to 324 thousandths in that direction. Once I'm there, I'll have finished my cut. I'm going to return past 0 and come back to 0 to take up my backlash. And then from there, I'll be ready for my next cut. They said I was mad. They said it couldn't be done. But who's laughing now? But I don't have my profile yet. Now I have a scalloped surface. The bottom of each groove is precisely on the profile that I want, my 3/4 inch half ball. So what am I going to do to finish this accurately? Well, I'm going to apply some layout blue. Actually, I'm going to use a Sharpie. And then with a very fine file, I'm going to come and file away the crests on each one of those grooves. Once that is done, I'll notice that the blue is now a series of lines. And I will continue to gradually file down those crests until I have just barely erased the layout blue that I applied. And at that point, well, I'll be ready for polishing because I'm going to have the required or the desired profile, my 3/4 inch half ball. Let's take a look at that. And there you have it, a nice and accurate 3/4 inch half ball. Well, I hope you've had as much fun watching this video as I've had fun producing it. I've been clued into the importance of the like button in positioning videos as far as the selection algorithms of YouTube go. So I'll say what I don't usually say is, if you like this video, don't be shy. Click the like button under the video. If you don't like it, well, just don't do anything. It's not important. But as I always say, have fun, be safe, and happy machining.